Okay, hi everybody. As promised, I am doing this entire lesson from the beginning, even though we have done about half of it already in class. Okay, so if you already have the first half mastered, you can skip on to where we have left off in class. Okay, let's get right into it. We are doing volume of various figures, both prisms and cylinders today. And so to get ready for that, they do now ask us to find the area of a triangle and a circle. Okay? A triangle, we find the area with this formula that we've used many times before. Area equals 1/2 base times height. And so the only thing we have to do in order to find the area is simply plug in for base and height. So these two are the only ones that we need to replace. Okay? So we do area equals 1/2 times the base, which is 6 feet. They tell us right here. And times the height, which is 3 feet. They tell us up here. Okay? So times 3 feet. And then we just multiply these numbers together. Okay? 1/2 times 6 is 3. So area equals 3 feet. And then we just bring down this other 3 feet times 3 feet. And then 3 times 3, everyone knows, is 9. And notice we have feet times feet. And so we were talking about area, so we know that that is measured in square units. So it's 9 feet squared. That is our area of this triangle. Okay? This triangle right here, that would have a base of 6 feet and a height of 3 feet. Okay? And we are done. So we move on to finding the area of the circle, a circle with radius of 5 inches. So first thing I'm going to do is draw my figure, and I know that I have a radius of 5 inches. And then I just remember from previous class that our formula for area of a circle is equal to pi r squared. Okay? And again, the only thing that we actually have to fill in then is the radius, because pi is a number. However, we will have to find a perfect answer and an approximate answer here. So area equals pi times the radius, which is 5 inches squared. Okay? And once again, when we are multiplying 5 inches times 5 inches, this is the same thing as saying area equals pi times 5 inches times 5 inches. Okay? 5 inches times 5 inches, 5 times 5 is 25. Inches times inches is inches squared. So I get area equals pi times 25 inches squared. However, we don't really like to write it this way, so what we prefer to write instead is area equals 25 pi. We always want the number in front of pi, and then inches squared is still our units. And that is our perfect answer for the area of this circle. However, we also want an approximation. Okay? So we will do area is approximately equal to 25 times, instead of pi, 3.14. Okay? And so we get area is approximately equal to, I'm going to use a calculator, but you guys all know how to do this with pen and pencil. 25 times 3.14 is approximately 78.5 inches squared, or square inches. And that is our approximate answer. The one, this is in terms of pi, and this one here is approximate, or to the nearest tenth. Okay? And so we can move on to the meat of the lesson. Okay? These 3D shapes we have seen before. The first two are called prisms. This is a triangular prism. This is a rectangular prism. A prism is is a figure that has the same shape on both bases. Okay? This triangular prism has two triangles, top and bottom, and they are the same size. This rectangular prism has the same rectangular base, top and bottom, and then the height is just what connects them. Okay? The third figure is a little different. It is a cylinder. It, once again, has the same shape, top and bottom, but it doesn't actually have a shape with lines. It has two circles. So a cylinder is a special kind, or is kind of like a prism, but it's unique because it does not have lines. It just has two circles. So we have cylinders and prisms, and they all, no matter whether you're talking about prisms or cylinders, they all have two items. They have a height, and they have a base. Okay? And that is what we need to know so that we can start talking about volume. Okay? So, we have the volume of a prism and the volume of prisms and cylinders. Okay? So I have already written this out here. To find the volume of a prism, it is just the area of the base times the height. Okay, so you can do area of the base times the height. So all you need to do then is find out what shape is my base and how do I find the area for that shape. Okay, so for our rectangular prism, a rectangle, we've known how to find the area forever. The area is just length times width. So we say that the base is 2 times, they're actually calling, I apologize, they're calling the base this part right here. I had called it the other end. It doesn't really matter, but they're saying that the area of the base is 5 times 2, because it's length times width. So we get 10 units squared. Notice the square because this is area right now that we're talking about. We just found the area of these bases here. And then what I will do is I will multiply by the height to complete the volume. And here is my height right here. So I get my area, 10, times 3, and I get 30. And notice now we're talking about cube units because we're talking about volume. Volume fills up something. It has 3 dimensions, so we need cube units. The cylinder is very similar. The volume of a cylinder is, once again, the area of the base times the height. Okay, so we look at the base. It is a circle. Both bases are circles. And so we find the area of the base. And we know the area from the do now, the area of a circle is pi r squared. Okay? So all I will do is I will replace my radius. So area equals pi times radius, which is 2, squared. And this is area equals pi times 4, or 4 pi. Okay? Now that I have the area of the base, this is really the same thing they did up here, I get 4 pi units squared because we're talking about area. Then again, just like what I did up here, by multiplying the base by the height, I will do the same thing here. I multiply the base that I just found right here, and I multiply it by the height, which is 6. So I do 4 pi times 6, gives me 24 pi. This is units cubed, 24 pi units cubed. And then when we approximate that, we just do 24 times 3.14 for pi. Okay, and we get 75.4 units cubed, approximately. So we need to talk about what our formula for volume of these shapes is. The volume, sorry, not what I meant to do. The volume for a prism is just the area of the base times the height. We say BH, but make sure that you understand that B means area of base. Okay? Area of the base. And then over here, the volume of a cylinder is a little bit different. We get the area of my base or the volume is base times height. The area of the base, again, this B once again stands for the area of the base, times the height. And what we can say is that we know that if we were talking about a cylinder, our base is a circle, and the area of a circle is pi r squared. So we'll just do pi r squared times h. I think it is easier to remember the formula volume equals base times height, but however you prefer to remember it is fine. Whether you want to memorize that that this volume here for the cylinder is pi r squared h, or whether you want to remember base times height is up to you. Okay? One thing to keep in mind though, area is measured in square units. Volume is always measured in cubic units. Okay. We are now, I think we skipped a page here. I apologize. So, it asks us here to find the volume of each figure to the nearest tenth, and when necessary, use 3.14 for pi. So they ask us for a rectangular prism with base 7 centimeters by 5 centimeters. So I'll just draw that in, 5 centimeters, 7 centimeters, and a height of 3 centimeters. So I've got this thing, and the height is 3 centimeters. Always a good idea to draw a picture, even if you can't draw like me, just to remind yourself what we're doing. And then we use our formula for volume. Volume equals base times height. But for the base, we're talking about the area of our base. And the area of the base equals length times width. And so I do area equals length, which is 7 centimeters, times the width, which is 5 centimeters. And I multiply those together. 7 times 5 is 35. Centimeters times centimeters is centimeters squared, because I'm talking about area. Okay? And then, once I have that, I continue my formula for volume, but instead of the B, I will just put in the area I have already found, right, for B. So I get volume equals base times height, but I know my base is 35 centimeters squared. Okay. Good. Volume equals 35 centimeters squared times the height, and then I will just plug in for h, the height, which I know is 3 inches. So this is equal to 35 centimeters squared times my height, which is 3 centimeters. Okay? And then I will just multiply. 35 times 3, I'll do it up here, 35 times 3, 5, 1, we get 105, so volume is 105. And centimeters squared, I want you to be very careful about this, centimeters squared times centimeters, there are actually 2 centimeters right here, 1 centimeter here. When we multiply them all together, we get 105 centimeters cubed. Do not try to plug in pi anywhere, because it's nowhere in our formula. When we have a rectangular prism, there's no pi. Not to be confused with the next one, where there will be. Okay? The cylinder to the right is 12 inches, pi 4 inches as the radius of the base. And so we will start with our formula again. Volume equals base times height. And remember, the base is area of the base, which we will do separately. Base is equal to the area of a circle. The area of a circle is equal to pi r squared. And our radius here is 4, so we do area equals pi times 4 squared. 4 squared is 16, So we do area equals 16 pi, and we don't forget that our units now that we're talking about area are square units. Area equals 16 pi square units. Now that I have that, I will come back here and I will plug it in right here. Base is 16 pi inches squared. And I will bring the rest of my formula down. Volume equals the area of the base, which we've already found, times the height, which we will replace with 12 inches in the next step. Okay? Just give myself a little more room. Okay? So, the volume is equal to this 16 pi inches squared times my h, which I now know is 12 inches. And then all that's left to do is multiply 12 by 16, which is 192. Volume equals 192. But do not forget about this pi guy, because we haven't talked about it yet. So it's 192 pi. And then we're talking about volume. Our units are inches cubed. So we get volume equals 192 inches cubed. Need just a tiny bit more room. Okay, so we've got 192 pi inches cubed, which is our perfect answer. But remember, the question asked me to approximate it to the nearest tenth, so I will do volume equals 192 times 3.14 inches cubed. And when I do that multiplication, I get 602. I apologize. I made one mistake first. This is not equals. This should be volume is approximately equal to 192 times 3.14. And so I get volume is approximately equal to 602.88 inches cubed. But remember, the question asked for it to the nearest tenth. So we will say volume is approximately equal to 602, and I will round this 0.8 up to 0.9 because the digit after it is 5 or higher. So inches cubed. Okay? And that is our approximate answer. And then we can move to the next one, which should be just a little bit easier. We are talking about the volume of a triangular prism. Okay? And so we get volume equals, again, base times height. However, our base, once again, is a little bit different, so we need to do that separately. The area of the base is now, well, what shape is this? It's a triangle. So our area of our base is the area of a triangle. Okay? And the area of a triangle is equal to 1/2 base times height. Now let me take a second to point this out. This h right here, this height, is not referring to the height of the figure. It is not talking about the 7 feet there. It is talking about the height of the triangle. That's this bit right here, the height of the triangle. It's drawn in right here and labeled 5 feet. Okay? So don't make that mistake. So the area is equal to 1/2. The base of my triangle here was 6 feet. So 1/2 times 6 feet times the height, which is 5 feet. Okay? 1/2 times 6 feet is 3 feet times 5 feet. 3 times 5, as we all know, is 15. And feet times feet is feet squared. So we get 15 feet squared. We can then take this area and plug it back in for the base here in our formula. Volume equals base times the height. And I will just plug in that base, which was 15 feet squared, times my height. Now what I will do is I will replace the height as well. Now we are talking about the height of the figure, so I can say, hey, we're talking about this 7 feet now. You can also remember that's the only number we haven't used yet. So volume is equal to 15 feet squared times your height, which is 7 feet. Okay? 15 times 7 is most of the time 105. Feet squared times feet is feet cubed. And so we have our answer. Once again, we don't use 3.14 or pi because there's no circles in here, so we're not going to use pi at all. We have our answer, volume equals 105 cubic feet. And we're going to move on. Okay? It asks, this is a question for you guys to do. This is from page 270, number 1 through 3 on the textbook. This is for you to do. Find the volume of each figure to the nearest tenth. Use 3.14 for pi. If you haven't done this yet, you need to pause the video right now, copy down these questions, and answer them using the previous slide and what we have done so far in this lesson as your guide. And I am skipping ahead. A juice box measures 3 inches by 2 inches by 4 inches. Explain whether tripling the length, width, or height of a box would triple the amount of juice that the box holds. So very simply, what this is saying is we've got this normal juice box like everyone has undoubtedly seen before. We've got it that is 3 inches wide, or 3 inches long, 2 inches wide, and 4 inches high. And it will hold a certain amount of juice. The question is, if I tripled one and only one of these measurements, let's say I tripled the length, and I made this 3, instead of a 3, if I made it a 9, what would happen to the volume of juice that the box would hold? And that's what we're going to find out. And the way we're going to do it is by finding the original volume, and then finding each new volume if I tripled only one of them. So the original dimensions, volume is equal to length times width times height. And let me just take a second there to point that out. Length times width is the base of this figure. Okay, so it's really base times height, but we can say length times width because the base of a rectangle is the length times the height. Okay, the length is 3, the width is 2, the height is 4, so 3 times 2 times 4. And we end up getting 24 inches cubed. Nothing very hard there, just make sure you're using cubic units. Now what we want to do is, what would the volume be if instead of using the original measurements I have, if I kept the 2 and the 4 the same, but I tripled the length, I made it 9 again, okay? And now our formula for volume looks a little bit differently. We are still going to multiply the 3 sides together, but width and height stay the same. However, the length is now 3 times the original length. So what we'll do is 3 times this original length, which was 3, and so we end up getting 9 for that, and the 2 and the 4 stay the same, and we just multiply those numbers together. We get 72 inches cubed. Okay? You can very quickly figure out that 24 times 3 gives you 72. So in fact, by tripling the length, we tripled the volume in the juice box. Now we're going to try the same thing, but with width and length, or width and height, but we're going to do it separately. For this one right here, triple the width, okay? All I want to do is keep my original measurements the same, except for the width, and I will multiply that by 3. So volume is equal to length. This time we're multiplying 3 times the original width. The original width, remember, was 2, okay? From over here. So the original width was 2, so we do 3 times 2, and then times the length times the width times the height. So the length is still 3, the height is still 4, but now our width is 6. And we want to know, if we multiply these numbers together, what do we get? We get 72 inches cubed. So if we multiply the length by 3, we get 3 times the volume. If we multiply the width by 3, we get 3 times the volume, and let's see if that holds for the height as well. Our volume is going to be length times width times now 3h, 3 times the height. My original height was 4 inches, okay? So I will do length times width, which is 3 times 2, but now instead of the height being 4, the height is 12. So 3 times 2 times 12, we multiply those together, we once again get 72 inches cubed. So when we're talking about a rectangular prism, the way it works is if we multiply any side by a number, say in this case by 3 to make it 3 times bigger, we will do the same thing to the volume. We will make the volume 3 times bigger. If we made the height, say, half as big as it originally was, our volume would become half as big as it originally was. Okay? The same is not true, however, of a juice can. A juice can, think about, is a cylinder. So we have a different formula for cylinder, even though the formula really is base times height. The base is a different shape, so our formula for volume is a little bit different. It is the area of a circle, pi r squared, times the h, times the height. Okay? So let's just put in our dimensions here. We have 2 inches for our radius, and we have 5 inches for our height. And then we will use our formula for volume. We'll find the area of the circle first, pi times r squared, which is pi times 2 squared. 2 squared is 4. Okay, so this is our radius squared. 2 times 2 is 4. And then 4 times 5 gives us our 20, and the pi just drops down. We get 20 pi inches cubed for our original volume of our juice can. Now, what happens if we triple the height? I'm going to skip tripling the radius for a second. What happens if we triple the height? Well, the formula stays the same. The volume is pi r squared, except that my height is now 3 times my original height. Remember, my original height was 5 inches. So now I'm going to do pi r squared times 3 times my height, which is, my radius is still 2. So I get 2 squared for my radius. Pi stays pi, but now my height is 15. When I multiply 2 times 2, I get 4. And then 4 times 15, I get 60. And the pi just drops down again because it's 60 times pi. So 60 times pi inches cubed. So when I tripled the height here, what I really did over here was I tripled the volume times 3 volume. Okay? 20 pi times 3 gives you 60 pi. Now let's see what happens when we do the same thing to the radius. The radius would be what changes here, and instead of being 2, we would multiply the radius by 3 to triple it, meaning that 3 times 2 would become 6. And let's see what happens in our formula here. Okay? We get 6 squared, okay? 6 squared pi equals 5. All right? And the reason for that is we had this one away. We got 6 squared. 6 squared is going to be multiplied by pi and by h, which is 5. And when we do 6 squared, we get 36 times 5 times pi. 36 times 5 times pi is 180 times pi. If you think about it, 2 times what number gives you 18? That's 2 times 9. So 20 times 9 gives you 180. So what we did when we tripled the radius, we actually multiplied the volume by 9. Okay? So we get something very different here. And the reason for that is this square term here. We have volume equals pi r squared h. This r, when we multiply that by 3, we do 3 times r, and then we square the whole thing. So what we're doing is we're really putting in our formula volume equals pi times 9r squared times h. So we're actually multiplying by this 9 here. Okay? I'm going to have a practice question for you guys to work on now. Okay, a jewelry box measured 7 inches by 5 inches by 8 inches. Explain whether increasing the height 4 times from 8 inches to 32 inches would increase the volume 4 times. What that is saying is that if my height, okay, which one was the height? The height is 8 here. If I change the 8 to 32 inches, what would happen to the original volume? Would it increase? Would it increase by how much? This is for you to do. Okay? Okay, and we have an exit ticket that we have done in class. A cylinder measures 3 centimeters tall with a radius of 2 centimeters. Find the volume of the cylinder, and then find the volume of the cylinder after doubling the radius. Explain how the volumes compare after this doubling. Are they the same? Does the new cylinder have twice the volume, etc.? Okay? If you did not finish this in class, or even if you did, being able to do this right now is key to being able to do well on the test next week. Okay? And I am going to stop my video right here, and I'm actually going to make a second one.